All right, to practice star problems, we're going to use two examples here. As usual, I made these both up. I didn't look up specifics. So while this might not necessarily be possible, the situations I'm describing here, that would only become an issue once we actually got into Pub 229, which for the example, for the instance of these examples, we're not going to do because the process of Pub 229 is identical between the star and the sun. It doesn't matter what body you're using, you're still going to put in declination and assume latitude and LHA, and you're still going to come out with the same answer. So that doesn't matter. And we're not going to be plotting these either. We're just going to work out until we get our declination and our latitude and our LHA to use for these problems, because that's the only part that is different besides also HO, which we'll find HO as well. So you can see here, this first problem, we have the 23rd of March at 1950. Spica's HS was 33 degrees, 21 minutes. We have our DR position for the time. I'm not going to make us advance or find new DRs. We're going to have it for the exact time. We have our chronometer time, our error, our height of eye, and our index error. And for this, we're going to do the same thing here. We have on the 1st of August with Arcturus, it had a height of 45 degrees, 50 minutes. It might be, in my experience, I think I remember Arcturus is usually pretty high in the sky, but I don't know if this is all correct. Regardless, let's start off with Spica here. So everything starts off the same way. First, we have to just find our time. So we're going to write zone time, zone description, then chronometer time, chronometer error, and GMT. We're going to break these up because we remember zone time and zone description go to affecting the hour, and chronometer time and chronometer error will affect the minutes and seconds. So we'll fill this in. Our zone time is 1950. Our zone description, my calculator. We don't have our zone description, but we have our longitude at the time is 60 degrees west. We can do the math, but remember you just divide the longitude by 15 and we get 4 here. So we're in zone description plus 4 because we're in the west, so we add. Chronometer time, we have 11:49:21, and our chronometer error is 0 minutes 40 seconds slow. So now what we do is we bring this down. Remember, if chronometer error is slow, that means you add because you need to catch up. If it's fast, you subtract from the chronometer time. So 40 seconds plus 21, that is 61. So you carry over the 60, you get 1 second, meaning this carries over to 50 minutes. So we have 50:01. And now the time, we don't know if this is 11 or 23. So we base that off of the zone description and zone time. So we do 19 plus 4, we get 23. So our true GMT time for this shot was 23:50:01. Now that we have that ready, we can actually start on the GHA calculations. So if we go back to a sun problem, you can see how we set up the GHA table is we do our GHA hours, our minutes and seconds, and then we find our GHA. Remember, this is only possible because we're always working with the sun here. But here we're working between the sun between Aries and the star. So what we're going to write is GHA of Aries. Remember, that's the symbol for Aries. And we're going to do minutes and seconds. So technically, this is GHA hours of Aries. Minutes and seconds. Then GHA of Aries for when we've applied these two together and we've gotten our true value of Aries here. Then we will write SHA, and then we'll write GHA of the star. Now, if you wanted to, I think this is the best way to break it down, because you've got this block, we'll actually separate it. This block here, which is only worrying about Aries, and then this block here, which brings you to the star. But technically, you're adding all of these values together. You're just adding this, and then you're adding this. So you could reverse the two, and you could do GHA, and then SHA, and then the minutes and seconds. But that is confusing, because then they're just kind of abstract numbers. They don't mean anything until you get to the end. Doing it in this order, I think, keeps the logic present. Then off to the side here, we're just going to really quickly write declination and assumed latitude, because remember, you can do declination at the same time as you work on GHA, so we just want to have that ready. So first step is we open up to the day, 23rd of March. Here. And instead of using this side, like we have been for the sun, we're going to work here. So here's the 23rd of March. We are looking for 2300 as our hours. So we come down, there's 2300. You can see the GHA of Aries at 2300 was 166 degrees, 20.3 minutes. So we write 166 degrees, 20.3 minutes. Now before we skip over to minutes and seconds, we can still get more information from this page, because right here are all the SHA values of the stars. We are working with Spica. So we look down the page, it's alphabetical. Come down here, and Sabik, Spica, right at the very bottom. There you go. And you can see this first section here is your SHA, and then your declination. So we're going to check the SHA first. We've got 158 degrees, 56.9 minutes. So we'll write that here. 156 degrees, 158 degrees, 56.9 minutes. Next, what we can look for is our declination. So you can see right next to Spica's GHA is its declination. South 11 degrees, 3.8 minutes. South 11 degrees, 03.8 minutes. Remember, declination is not going to change fast enough for it to be worthwhile even worrying about in the difference in time between 2300 that day and 2350 that day. It's going to change by maybe 1,000th of a degree or 1,000th of a minute. I don't know exactly, but it's so minor that there's no point in worrying about it. So this is already our correct declination. We don't have to go into any more detail on that. And our assumed latitude we can do real quick. You can see our latitude in the problem was 22 degrees 15 north, so we'll just do 22 degrees north for that. Now we can get back to this section here. Next we need the minutes and seconds. So we're looking for 50 minutes, 1 second. We come to our increments, corrections section in the back of the book. Here we go. We're at 12 minutes here, so we're going to skip over a few more pages. 47, 48, 49. Here's 50. Now, we're not going to use this column. We're going to use the Aries column. If you ever forget, just look for what body you're measuring off of and take that column. So we're looking for 50 minutes and 1 second. So it happens to be the second point here. We can see Aries, its GHA changed by 12 degrees. Oh, it's blurry. Changed by 12 degrees, 32.3 minutes. So for the minutes and seconds correction, we're going to do 12 degrees, 32.3 minutes. 2.3 minutes. Good. Now, remember your minutes and seconds are always just added to the hours. So we're just going to do 20.3 plus 32.3. Our minutes become 52.6 minutes. Then 1 66 plus 12, 178. So our GHA of Aries at the exact time of the shot was 178 degrees, 52.6 minutes. Good. What we want, though, is the GHA of the star, of Spica specifically. So we're going to add the two together. Remember, it's always add. There's no ambiguity about it. You're just going to add GHA. Where is it? Just going to add GHA, or this is GHA. You're just going to add GHA to SHA. And you're going to get the SHA, the GHA of the star. So we do 52.6 plus 56.9. It's 109.5, so we carry the 1. 49.5 minutes. And now that we've carried the 1, we're going to do 179 plus 158. We have 337 degrees. Okay, so the GHA of our star was 337 degrees. I was kind of hoping that I'd guessed on one that would get above 360 so we could show that. But remember, if it were above 360, you just subtract 360. Next, we need to find our LHA. So we're going to have a section for our assumed longitude and then a section for our LHA. Step 1 is to set our assumed longitude. So remember, we are in the west. And when you're in the west, you subtract the values of, well, actually, let's just draw it out so we remember. There's our diagram. Ourselves. We're in the west, meaning Greenwich is somewhere over here. Now we know the GHA of the star is 337 degrees. So the GHA of the star is, we wrap around just about there, actually. Or sorry, not GHA, yeah, it is the GHA of the star. So there's the star there. Here's our longitude. Here's the star's GHA. So if we want to get this distance here, all it is this minus this, which is going to get us, this minus this, which is going to get us a negative number, so we're going to have to add 360 to find the difference. So here we're going to subtract the 2 and then add 360. Remember, LHA is equal to assumed longitude minus GHA plus 360. So now we need to set our assumed longitude. Remember, we want LHA to come out to be a whole degree value. So we want it to have a minute value that's going to cancel out and come to 0 when we subtract it from the GHA. And how we're going to do that, so we're going to set it as 49.5. So our minute value of assumed longitude is 49.5. However, we want the degree value to bring us to within 30 minutes of our actual DR position. So remember, our actual DR position is 60 degrees, 10 minutes. So how we choose between the three is you set your 3 meridians right there. You set them each to have a minute value of 49.5. And you set them each a degree apart, with the central one being 60 degrees west. So then this one's 61 degrees west, and this one is 59 degrees west, so that you can make a concise decision between which one your DR position would fall closest to. So if we're working with 60 degrees, 10 minutes west, you can see that the closest one to 60 degrees, 10 minutes is this one. It would fall right around here. it's closest to 59 degrees, 49.5 minutes west. So we're going to set our assumed longitude as that, 59 degrees, 49.5 minutes west. I see what I did wrong. I placed us in the east, not the west, and that's why this was confusing me, and that's why I probably confused you. Let's just really quickly switch that around so that makes more sense. Here's Greenwich. Here's us. So then this is our longitude, and that's our GHA. Those two are nothing. And that, that is our GHA. This is our LHA. This is our longitude. In which case, yes, you subtract your longitude from your GHA, and that will get you this distance here, which will be our LHA. I'm sorry that I messed that up. So ultimately, just remember east add, west subtract, and do the diagram. Even if it confuses you, it will eventually make things clearer. Just make sure you don't mess up. 337 minus 59, because we can ignore the minute values because they just come out to 0. We get 278. 278 degrees. Okay, and that would be the process for getting the LHA and declination of the star. Remember, the one thing we have to do, though, is we still have to find HO, because that is also different from the HO of the sun. So we'll write HS, IE, dip, HA, main, HO. And we follow this process through. So HS was 33 degrees, 21 minutes. Index error is 0.9 minutes on. Height of I is 51 feet, which will create our dip value. And that's all we have so far. So step 1, index error. If it's on, you subtract. If it's off, you add, because this is describing how if it's more or less arc than you wanted. So we're going to do minus 0.9 minutes. So we do 21 minus 0.9. Gets us 20.1. But then the next step, we have to find our dip correction. So we come to the first page of the book. We come over to the dip section, and we see, what was it, 51 feet? For a height of 51 feet, we go between 49 and 51.3, and we get minus 6.9 minutes. So we do minus 6.9 minutes. So we continue to subtract from 20.1, and we get 13.2 minutes. So our HA, our apparent altitude, is 33 degrees, 13.2 minutes. Now we come back here, and we're gonna correct that using the main body correction. Luckily for stars, it's nice and simple. You just use this column. You don't worry about the time of year or the upper or lower limb, because stars are dots. There are no upper or lower limb for stars. And we just find what this is equivalent to. So 33 degrees, 13. We get 33 degrees to 45, so we go 1 down, minus 1.5. So subtract 1.5 minutes. And we're going to do 13.2, 13.2 minus 1.5, 11.7. So the HO of the star is 33 degrees, 11.7 minutes. I blew through that really quickly because it's not that hard, but even still, all you need to remember is that this main body correction you take from a different column, and it's the column labeled for stars. For GHA, just to include SHA. For declination, also simpler. You just grab what the declination says. Let's try it again for this one. So 1st of August for Arcturus. Zoom in a little bit more, and I hope you can focus. We'll see how quickly we can run through this one. So remember, zone time, zone description, chronometer time, chronometer error, GMT. Some teachers will actually have, as part of the test, writing out this, just the steps you need to take without ever actually doing any of the math to see if you can remember that part. Even if you can't memorize it just yet, just get into the practice of that. Eventually you'll know what steps are necessary more than you'll know like what letters are supposed to go where. So zone time was 2010. Let's break it up like this. Our zone description, well, we're 130 degrees east. So if we do 130 divided by 15, we get 8.6. So we round 8.6 to 9. And then we remember we're in the east, so it's negative. So we have minus 9. Chronometer time is 11:50. Chronometer error is minute 10 seconds fast. So for chronometer error, we subtract. So we subtract because it's fast. We need to slow it down. 50 minus 10 is 40. 11 minus 1 is 10. And then for the hours, we take the zone description, zone time, subtract the zone description, we get 11. So our GMT time for the shot is 11, 10, and 40 seconds. Now we can move on to our GHA, finding our LHA. So we're going to write GHA hours of Aries. We're going to write minutes and seconds. Then we're going to get the GHA of Aries. After that, we're going to write SHA and GHA of the star. Then underneath that, just to get ahead, we're going to have our assumed longitude and our LHA. Then off to the side here, we're going to put down declination and assumed latitude. So we have those two ready as well. All right. We go to the book. We're looking for the 1st of August. August 23rd. Okay. August 1st. And because we're on the, because we happen to open to this side, you can see, coincidentally and interestingly, we've got an eclipse of the moon, or of the sun happening here that's shielding the moon from us. So you don't have information on the moon over here, which is cool. But we're going to come to the star side. And we're looking for the 1st of August. So we're looking for the GHA of Aries on the 1st of August at 1100. Right there, 114.57.9. 114 degrees, 57.9 minutes. But before we move on to minutes and seconds, let's get our other information. So we're going to come to the side here. We're now looking for Arcturus, which is there, Arcturus. Its SHA is 146 degrees, 17.9. 46 degrees, 17.9 minutes. And its declination is north 19 degrees, 17.0. North 19 degrees, 17.0 minutes. Okay. Now we have everything we need there. I've written it down. Now we got to go to the back of the book to get our minutes and seconds. So we're looking for 10 minutes, 40 seconds. Okay, 40, 20, 4, 12, 10, right over here. So 10 minutes, and we're going to come down to 40 seconds and read the Aries table. 40 is down here. 2 degrees, 40.4 minutes. 2 degrees, 40.4 minutes. Good. Now we can start adding things together. So, remember, just add minutes and seconds. So 57.9 plus 40.4 gets us minutes of 98.3, which if you subtract 60 is 38.3. Carry the 1, we get 115 plus 2 is 117. Now we got to add our GHA. So we do 38.3 plus 17.9 gets us 56.2 minutes. And 117 plus 146, 263 degrees. Again, I wish that it happened to go above 360, but just subtract 360 from that and you get your answer. All right. Now we need our assumed longitude. So firstly, let's find if we're adding or subtracting. Draw the Earth. Here's us. We're in the east, so I'm going to draw Greenwich here and actually be correct this time as opposed to last time. Say that this is our longitude here. The GHA of the star is 263, so it's about that way. Here's the star, meaning here is our GHA. So LHA is that we add. So adding the two together, that means that when we add these minutes together, they need to come to 0. So instead of setting it as equal to 56.2, we set it as the opposite, or not the opposite, but something that adds to 60. I'm just going to say complement from now on because that's the closest thing I can think of that would apply, but it's not technically correct. Either way, 03.8. When we add these two together, we'll get 60 minutes. Now to figure out our assumed longitude, set your 3 lines. Remember, we need the minute value to be 03.8. 03.8. 03.8. And then the degree values are based off of our DR position. So here's 130. We'll set that in the center. 130 degrees east. So this is 131 degrees east. And 129 degrees east. There we go. So amongst these options, which one is closest to our DR position of 130 degrees 15? Well, you look, 130 degrees 15 would land right here, closest to the center one, meaning we're going to use 130 degrees as our assumed longitude. So our assumed longitude is 130 degrees, 03.8 minutes east. I forgot to add the W for west on the other one. All right, now we add the two together. So we're going to do 56.2 plus 03.8, which we know comes out to 0. But we also know that that carries over a 1. So now we're going to do 264 plus 130. We get 394. Finally, I got one where we can do this. 394 is obviously above 360. So we're going to subtract 360 because all it means is that we wrapped around more than one full rotation. And we're going to get the true LHA is 034 degrees. 34 degrees is our LHA. By the way, our assumed latitude, we're doing 10 degrees, 10 minutes north is our DR latitude. So our assumed latitude is 10 degrees north. Now we have our 3 numbers that we could put into Pub 229 or the formula. Next, we're going to work out HS to HO. So HS, i.e. dip, HA, main, HO. Okay, HS is 45 degrees, 50 minutes. IE is 1.1 minute off. Height of I is 30 feet. So step 1 we'll do is finding dip, just so we don't have to interrupt ourselves halfway through. 30 feet. Wait. Yeah, 30 feet. If you look over to the dip table right there. Sorry, I'm kind of holding a lot here. we get minus 5, or actually minus 5.3. So we'll do minus 5.3 minutes. Then we do 50 plus 1.1 because we're doing off here. So if it's off, you add 50 plus 1.1 minus 5.3 gives us an apparent altitude 45 degrees, 45.8 minutes. Now we come back to the book and we look at what our main body correction is. So if our apparent altitude of a star is 45 degrees, 45.8 minutes, you can see we got 45.36, 48.47. So we take halfway between, minus 0.9. So minus 0.9, and we're going to get 45 degrees, 44.9 minutes as our HO. Nice and easy. I like stars more than I like the sun. Obviously, SHA, not that hard to do. Declination, easier than it is for the sun. So altogether, I consider them less total work.